So now let's see H plane T. So your H plane is formed by attaching a rectangular waveguide in the narrower band, okay, narrower side. Whereas in your E plane we attach the waveguide at the broader side, and here we are attaching the extra arm on the third arm at the narrow side of the waveguide. Okay, so this 1 and 2 it is called as collinear arm, as we know, and this third arm it is called as side arm or H arm, right? And here it is also called as sum arm, whereas in your E plane we said it is a difference arm. Here it is also called as sum arm, and your H plane T it is called as your shunt T. Okay, it is called as your shunt T, whereas in your E plane it was called as series T, right? So here the axis of your side arm is parallel to the magnetic field, that is why it is called as H plane T. Okay, in E plane it was parallel to the E field, right, electric field, that's why it is called as E plane. Here it is parallel to the magnetic field, that is why it is called as H plane. Okay, so let us move on to the scattering matrix. So this is also 3-port network. So since it is 3-port network, we say it is having a matrix of order n cross n, so 3 cross 3. So since it is 3-port network, the possible parameters is 9 parameters, and we know in your H plane, so if this is my H plane, so port 1, port 2 and port 3, if I give input at port 3, so your port 1 and port will be equal in amplitude and in phase. Okay, it will have the output which is equal in amplitude and in phase. Okay, because of the plane of symmetry, right? So I can just write like S13 is equal to S23. So that is what I have written. And what is the next property? It is a symmetry property. Symmetry property, Sij is equal to Sji. So I can say S12 is equal to S21, S13 is equal to S31, S23 is equal to S23. So this I can replace here, right? So this is my matrix now. Now even I can say this third port which is attached, right, to the junction. So this third port which is attached to the junction is perfectly matched to the waveguide, so I can say Sii equal to 0, because this is my third port. I say S33 equal to 0, so I have replaced it by 0, right? So what is the next property? Multiplying the scattering matrix with its complex conjugate, which is going to yield an unit matrix, right? Okay, and what is the next property? If I multiply and sum the different rows and different columns, I should be equating it to 0. If I am doing it for same row same column, then I have to equate it to 1. So from this equation I can write for R1 C1 row 1 column 1, I have to equate it to 1 because it is of same 1 1. Same way I have to equate it to 1 if it is R2 C2, R3 C3. I can do it for all these things similarly, right? And for R3 C1, because it is of different row different column, I have to equate it to 0. Now I have to take these 4 equations, I have to solve, and I have to find out the 4 unknown components which we have substituted in the matrix, right? So from this I can write from this equation number 5. Okay, so equation number 5, this, from this I can write what is S13. So it is 2 S13 square equal to 1, so S13 is equal to 1 by root 2, right? From this I can calculate S13, and from this equation 3 and 4, if I equate this, so I can eliminate S12 S12 S13 S13, so I can say S11 is equal to S22, right? Yeah, so I can write S11 equal to S22, and from the last equation if I equate, so there it is S13 S11 star plus S13 S12 star equal to 0. You have to equal it to 0 because it is row 3 column 1, and so here S13 is common, so I am taking S13 as common, S11 star plus S12 star equal to 0. S13 will not be equal to 0 because I know the value of S13, it is 1 by root 2, so this is not equal to 0, so I have to definitely equate this to 0. So if I equate this to 0, I can write S11 is equal to S12 minus S12, right? Okay, next, so substituting that in the third equation, I can find out what is S111. So since I know S11 is equal to minus S12, so S12 is equal to minus 1 by 2, and also we know S11 is equal to S22, so I can write S1, all the 4 parameters I have found out now. Substitute all the parameters in the matrix, so I will get, this is my matrix. Okay, so from this is the matrix of your H plane. Now from this I can write the equation for my reflected wave. So reflected wave is equal to scattering matrix into my incident wave matrix. So how many port I have? 3 ports. So B1, B2, B3, A1, A2, A3. So from this I can write as a equation. So I can write like B1 is equal to A1 by 2 minus A2 by 2 plus A3 by root 2, and same way B2 minus A1 by 2 plus A2 by 2 plus A3 by root 2, and B3 is equal to A1 by root 2 plus A2 by root 2, right. So now I can see for different cases as I did for E matrix. Yes, so I'll assume for the case 1, so A3 case 1, I will take A3 is not equal to 0, A1 equal to A2 equal to 0. If this is the case, what will happen to my reflected wave? So what is the meaning of this? I am not giving any input at port 3, right. Sorry, I am not giving any input at port 1 and port 2, I am giving input at port 3, right. So no input at port 1 and port 3. So if I substitute in H plane this equation, I will get B1 equal to A3 by root 2, B2 is equal to A3 by root 2, and B3 is equal to 0. So what do you understand from that? If I give input at port 3, it is equally dividing into equal magnitude and phase, right. So case 2, next I can take case 2, case 3, right. So I can say A3 equal to 0 and A1 and A2 equal to A. So like this you can do it for different cases and you can find out, right. So it should satisfy the sum. This is your sum arm, right. So if I substitute this, what will happen for B1? So A3 is 0, so I will have A1 by 2, it is A, right. So it is A, I can write like A minus A by 2, A3 is 0, same way B2 minus A by 2 plus A by 2 plus 0, and B3 it is A by root 2 plus A by root 2. So if I give input at port 1 and port 2, so I am not getting anything at port 1 and port 2, I am getting at port 3. It is summing up, see, the input is summed up. So this is why it is called as sum arm. Likewise I can take it for different cases and I can solve it for different conditions. So this is my H plane.